Good evening and welcome to TL Physics, and today I'm going to talk about equilibrium. Now, you may have been told about equilibrium before in terms of forces. So you may have had a block, and if it's being pulled this way with 5 newtons, that for it to be in equilibrium there must be a force in the opposite direction of the same amount, or a sum of. So if I had 5 newtons in total this way, I must have 5 newtons pulling me in total this way, and I'll be in equilibrium. I won't be moving. Now, that is for equilibrium of forces. For true equilibrium, not only are my forces to be balanced, but my turning effect also needs to be balanced too. I must not be spinning clockwise or anti-clockwise. So for true equilibrium, my resultant force must be 0, but my resultant moment must also be 0. I've got an example question here. I have a system of a block with a pivot. So here's my pivot. So I've got a 12-meter long beam that has a weight of 5 newtons, and it is acting, this pivot is acting 2 meters in. I've got a force of 10 newtons this way, 30 newtons 5 meters from the pivot, and 10 meters away I've got this force A. And I would like to find the reaction at the pivot and the force A for equilibrium. So I need to try and find the value for the force of A and a reaction force at the pivot that will make equilibrium. So the first thing I have to do with this is actually label forces on the diagram. So firstly, I need to actually add my reaction force at the pivot. And reaction forces are from Newton's third law, and they're all about acting in a direction. Okay, so this direction here, and it is, I've put it upwards. This may find out to be negative, so it might be actually working the other way, but I'm arbitrarily putting it here for now. So this is due to the fact that the pivot is on another surface and it's having a contact. So Newton's third law, if I put force on A will put an equal or opposite force upon me. I also need to put the weight on here. And this is actually important because sometimes exam questions will do this. And how I know where to put this is all to do with something called the centre of mass. And the centre of mass is the point at which we say weight acts through. What that means is this is a meter ruler, and this is a nice, hopefully, a nice uniform material. And what it basically, if you think about it, there's weight all over this thing. But basically there must be a point where the amount of weight this side of my finger, which is turning it this way, is equal to the amount of weight this side trying to turn it the other way. And this point on a ruler is approximately around 50-ish centimetres. It's directly in the middle because this is hopefully a nice uniform sort of beam. And as you can see, sometimes it tilts the other side. There we go. So that here is at the centre of mass. So what we say is this point where my finger is where all the weight acts. It is the point at which this object is balanced. That the moment caused by the weight this side of my finger and the moment at which the weight on this side it's causing on this side are equal. Okay. So on this diagram, this object is 12 meters long. It is going to act in the middle. So it's going to act 6 meters from the edge. So 6 meters from the edge to the pivot. So it's going to be 4 meters from the pivot. And of course it's weight, so it's going to act downwards. And I'm going to write that there as 5 newtons. So how do you solve this? Well, first of all, I've got 2 unknown forces. And the first thing I'm going to do is look at moments. And you very cleverly always choose one of your unknowns as the pivot. The reason being is that it completely ignores the force. Any forces acting on a pivot don't have any effect with the moment. Think about it. If you sit on a seesaw, right in the middle, you don't rock either side, you just stay in the middle. Your force has no effect on the turning. So let's actually do this here. And first of all, I'm going to look at moments. And firstly, I'm going to look at any forces that spin me clockwise. So any force that spins me this way round, okay? So I draw a little symbol of clockwise and I get my ruler and I see which direction the forces are acting. Well, my 30 is going anti-clockwise, my A is going clockwise, my B, my 5 newtons is going clockwise, and this one here is also going clockwise. So 10 times 2 is 20. 4 times 5 is also 20. And I have, because remember it's from the distance from the pivot, and I've got this 10 times A. And I'm not too sure what A is, and I don't know what that is yet. Now, anti-clockwise, I only got one force. So here's my pivot, put my finger here. This 30. So 5 times 30 is 150 Newton meters. This means I know for it to be in equilibrium that all of these added up must equal 150 to cancel each other out. So far I have 40. So 40 plus 10A equals 150 Newton meters. 10A equals 110. So A is going to equal 11 newtons. So this here is going to be 11 newtons. I am now going to do my forces. So my forces up are going to be 10 plus 30, which equal plus R, equals 40 plus R, and my forces down are going to be 11 plus 5, which are 16. So I know 40 plus R must equal 16, which means here, so 40 plus R must equal 16, I know that R must equal minus 24 newtons. This negative sign means I got my R the wrong way round, which means instead of up it would be going down. That is how you solve a true equilibrium problem, when I'm looking very specifically firstly at the moments and then at the forces. By choosing a point as your pivot as a force that you don't know will really assist you in this.